Okay, Turing machines can implement functions, right? You can think of a Turing machine like a computer program. So we'd like to design a Turing machine that, given a input of a binary string, and that binary string is representing a number, we want it to halt with the output being that binary number increased by 1. So for example, if the tape started with a 101 on it and everything else blank, we'd like the Turing machine to do some stuff and then halt in a state when with the tape now reading 110. So take this number incremented by 1. So the first thing we should do before we even start constructing a Turing machine is to identify the algorithm we're going to use. So the algorithm we're going to use is we're going to start from the right-hand side, and because by default the tape head's on the left, we need to move the tape head to the right. And then starting from the right, if the bits are 0, we flip it to a 1 and then we're done. Otherwise, if it's a 1, we flip it to a 0 and then move to the next place and repeat. So for example, if I have this number and I add 1 to it, what happens? We get 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 0 is 1, and we stop, and then we copy the last bit down. So I can see by just flipping 1s to 0s until I see a 0, flip it to 1 and stop. That's going to implement this addition algorithm, right? So let's construct the Turing machine that will do that. So the first thing I want to do is rewind the tape all the way to the left. So by default, I point to the left-hand side. So if I see anything, leave it alone and then fly all the way to the right. So if I see a 1, right a 1, move right. If I see a 0, right a 0, move right. And then if I see a blank, I know I'm all the way on the right, so I'll take 1 step to the left. So I see a blank, right a blank, and move left. Sometimes we use lambda for blank, sometimes we use B, it's interchangeable notation. Really, these should be lambdas if I'm going to stick with the notation of the course. So let me put lambdas instead. Capital lambdas, there we go. So I'm on the left-hand side. What am I going to do? If I see a 0, flip it to a 1 and then halt. Halt in the accepting state. If I see a 1, flip it to a 0. Move left and then try again. And then I'm stuck in a loop, flipping 1s to 0s until I see a 0 and flip it to a 1. Okay? So let's try this Turing machine. So here will be my tape. Just trying the Turing machine is a really good way to test if your answer is correct. So I'm going to pick the numbers. I'll pick 1, 0, 1, 1. So that'll be my input. And the rest of the tape is blank. Okay? So by default, the tape head starts here. See a 1, right a 1, move right. See a 0, right a 0, move right. 1, move right, 1, move right. Blank. See a blank, right a blank, move left. And now I'm in state S1. Alright, so what happens now? See a 1, write a 0. So see a 1, I write a 0 to the tape. And then I move the tape head to the left. And then I transition back to S1. See a 1, write a 0. Move left, back to S1. See a 0, write a 1. And then transition to the halting state and then stop. That looks like it worked. The input was, so what was the input? The input was exactly this string here. And it looks like when it halted, the tape contained this string here. So it looks like it works. Okay. What about if we overflow? What happens if we have a string like 111 and I add 1 to it? 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. They have to create an extra place, right? So copy the 1 down. And this Turing machine is not going to account for that behavior because if we try running it, so let's make the tape all 1s. 1, there we go. Get my 0s here. So we start here on the left. See a 1, write a 1, move right, move right, move right. See a blank, write a blank, move left. See a 1, write a 0, move left. See a 1, write a 0, move left. See a 1, write a 0, move left. And then I'm stuck, so it halts, so the output's 3 zeros. Not ideal, right? It should be if I get all the way to the left and I fall off the end of the string and I see a blank, I should write a 1 and then halt. So we'll add that transition in. See a blank, write a 1, stay, and then hold. So in the position we were in, see a 1, write a 0, move left, and then see a blank, write a 1, stay, and then hold. So now it looks like this machine is correctly implementing the +1 function. Okay?